welcome to EC Electronics. So this is the lecture series of embedded system subject. We are going to discuss about the topic interrupt in this video. We'll be discussing about what is interrupt, what are the various type and sources of interrupts. Also, we'll be discussing about ISR, which is interrupt service routine, and context switching. Okay. So we'll be discussing these three topics together in this video. So this is a quick revision video of interrupt area. Okay. So let us first see what is an interrupt. Now, why this is called interrupt also we'll be seeing. Okay. So interrupt is actually a signal to the processor and it is emitted by hardware or software indicating an event needs immediate attention. Consider that there is a system and the processor of the system is doing some work. It is processing or it is doing some process or task. And at that time, any hardware or software in the device is requiring an immediate attention. And for getting the service from the processor, it raises a signal. And this signal is called interrupt. Now, why it is called interrupt? Because whenever this signal is coming, naturally what is happening is, when the interrupt signal is coming, the processor will stop whatever it is doing and will go and serve the signal and it will give assistance to the hardware or software which is demanding attention. Okay. So there is actually an interrupt or an interruption happening to the processor's routine. Okay. So whatever the processor was doing, it has to stop in order to serve the hardware or the software which is demanding the attention. It had to stop whatever it was doing. So this is why the signal is called an interrupt signal, because it is actually interrupting the normal operation of a processor. Okay. So this is a very brief and very good way of saying what is an interrupt. So an interrupt alerts the processor to a high priority condition requiring the interruption of a current code. Okay. So current code means whatever the processor is currently doing. And when an interrupt is coming, the current process or current code will be stopped and then the system or the processor will go and serve a high priority condition, okay, which is called an interrupt condition. Okay. So what will happen when an interrupt is coming? The processor will respond to the interrupt, that is an interrupt signal, by suspending its current activities, saving the state and the executing a function which is called interrupt handler to deal with the event. So whatever the processor is doing currently, it will stop it, and also it won't forget to save the state of that process. Okay. So whatever it is doing, it will stop, but it will save the state of that process and the details of that process to some place. And then it will go and serve the interrupt. After finishing the interrupt servicing, it will come back to the process which it was earlier doing. Okay. And it will resume that process. Okay. Now, what is an interrupt handler? Interrupt handler means it is a function which is used for serving the interrupt, or it is also called as interrupt service routine. So later on in this video itself, we'll be seeing what is an interrupt service routine. So just understand that in order to serve the interrupt, or in order to serve the demand of the hardware or software, a function is created which is called interrupt service routine. So this interrupt is actually executed in that interrupt service routine. Okay. So next one, the interrupt is temporary. So after the interrupt is finished, what will happen? The processor will come back to the normal activities. So it was actually doing an activity. While doing the activity, in between an interrupt has come. So the processor had to stop whatever it was doing. It had to save the current status and everything of the process, and it has gone to serve the interrupt. After finishing off with the interrupt, it will come back and resume the normal activities or whatever it was doing previously. Okay. So that is a interrupt. Next, let us see a diagram of interrupt. So whatever we have just discussed is actually explained with the help of a small diagram. Okay. So this is the state, or this is a normal functioning line. In between, you can see there is a yellow box which is actually indicating an interrupt, and then after finishing off the interrupt, it will go back to the the current activity or the normal activity. Again, here also another interrupt is coming, it is going back. After serving the interrupt, it is going back. Again, here also another interrupt is coming, then it is returning from the interrupt. So this is how the interrupt is processed. Now the interrupt is normally a high priority process or condition. Okay, so whenever a high priority condition is coming, the processor has to give assistance to that thing, right? So it will stop whatever it is doing and then it will process the interrupt. Okay, next let us see the sources of interrupt. You can broadly classify the sources of interrupt as two categories: hardware interrupt and software interrupt. Normally we say the software interrupts as exceptions. Hardware driven interrupts are only called as interrupts, but the software driven interrupts normally we call it as exceptions. Okay, let us discuss about the hardware interrupt sources. So the hardware interrupt sources can be external or internal. Now consider that there is a system and there is a board for the system. If any of the hardware component in that board is seeking, or inside the system itself, any hardware component is seeking some attention, or it requires some servicing, then it is called an internal hardware interrupt. But if any external hardware is demanding such service, then that type of interrupt is called external hardware driven interrupt. Okay. Now let us see some examples of internal hardware device sources, that is the interrupt sources. First one, parallel port, UART, synchronous receiver byte completion, then ADC start conversion, ADC end of conversion, real-time clock timeouts, watchdog timer, various timers. So these type of components which are present within the system itself will demand sometimes the attention, or sometimes it demands some servicing. And this type of sources are called internal hardware sources. Okay. Next, let us see the classification of hardware interrupts. Hardware interrupts can be classified as maskable interrupts and non-maskable interrupts. Hardware interrupts that can be delayed are called maskable interrupts. So consider that the processor was doing some activities or some processings, and at that time a device, that is a hardware device, had it is requiring a servicing or a assistance, and that time it raises a interrupt signal to the processor. But this hardware device, which is a low priority device, in that case that interrupt is maskable, means it can be delayed. So what the processor will do is it will finish whatever it is doing currently, and only after finishing that process, then it will process the interrupt. Okay, in between it won't break its current activity. Okay, so this type of interrupt is called a maskable interrupt. When a low priority hardware is asking for an assistance, it can be masked. This interrupt can be masked, so it is called maskable interrupt. Okay, next one is non-maskable interrupt. Non-maskable interrupt means this interrupt, if it is raised by a hardware device, then at any cost it has to be serviced or it has to be processed. Whatever the processor is doing currently, it has to stop that thing and it has to do the processing of this non-maskable interrupt. The very beautiful example of a non-maskable interrupt is a reset button. Consider that you are doing some coding or anything in 8051 microcontroller. You are actually doing a very big coding. Okay, in between you have pressed the reset button, means it is actually a non-maskable interrupt. Okay, so the processor, whatever it is doing, it will stop that immediately and it will service that condition. Okay, which is a reset condition. Okay, so this type of interrupts are non-maskable interrupts. I have just given you an example. There are other non-maskable interrupts also. Okay, next one, software interrupts. So as we have discussed, it is also called as exception. So software interrupt, the various conditions of software interrupt are, it can be related to the processor detecting a computational error, or division by zero, or illegal opcode, or overflow. Okay, so these are the various types of software interrupts. That is division by zero detection, divide by zero, it is a illegal condition, right? So whenever a division by zero is this condition has arrived, means it is a interrupt condition, right? It is a software driven interrupt. Okay, it is called as exception. Next, overflow detection by hardware. The hardware will be detecting it, but it is actually causing a problem to the software also. Okay, then underflow, illegal opcode, these are actually the software, that is the interrupts that are affecting the software. Okay, that is, they are connected with the software. Okay, so these type of interrupts are also called as exception. Next, let us see the classification of software interrupts. So the software interrupts can be classified as normal interrupts and exception. Normal interrupts means it is some software code or some software instruction we purposefully write for creating an interrupt. Okay, so when we are writing a code, we purposefully insert a interrupt in between by using some instruction. It is called as software interrupts or normal interrupts. Okay. Now, what is the exception? Exception means it is actually a unplanned condition. Consider that you are attempting a division by zero condition. It is an unplanned thing, right? But it will cause an interrupt. So, this type of unplanned things is called as exception. So, whenever there is a division by zero or whenever this exception condition is also happening, what the processor will do is it will stop whatever it is doing currently and then it will go and find a solution for this condition. That is division by zero. It has to be resolved, right? So, it will first find a solution for this condition and then it will come back and process whatever, or it will resume whatever it was doing. Okay. So these are two classifications of software interrupts, the normal software interrupts and exception conditions. Okay. Next one. Next, we are going to discuss about the interrupt service routine. Now, interrupt service routine is actually a small program that the processor execute when the corresponding interrupt is being requested. So, whenever a hardware is demanding a service, so there will be a particular routine or a code written for the processing of this service which is requested by a hardware. Okay, so the code that is written for serving the hardware, it is called a interrupt service routine. So when the hardware is demanding some assistance, it will raise an interrupt, right? And what type of servicing the hardware is demanding, what type of processing the hardware is requesting, all these things will be written inside a code or inside the small program which is called interrupt service routine. So this is the most simple explanation for an interrupt service routine. So whatever the interrupt is demanding, whatever the interrupt is requesting the processor to do, it is written in a small piece of program which is called a interrupt service routine. Okay. So what will happen when an interrupt is happening? That is, whenever an interrupt is coming, what will happen? What all things will happen? So when the interrupt is occurring, what will happen? The processor masks further external interrupts, save the current context on stack, then execute the appropriate interrupt service routine. Upon return from the ISR, restores the context and enable the interrupt and return. Okay. So this is the normal steps the processor will be doing when an interrupt is coming. Okay. So when an interrupt is coming, if it is a non-maskable type of interrupt, or if it is a high priority interrupt, what the processor will be doing? The processor will be masking further interrupt. Means no further interrupts can come at this time because it is already going to process one interrupt. So it can't take further interrupts. So it will mask all other interrupts which can occur. Then it will save the current data or current context or current program details to the stack. Then it will load the appropriate interrupt service routine, which is the program. And then it will do the processing of the ISR, which is the interrupt service routine. And upon finishing the interrupt processing, then it will restore the context, restore or resume to the normal processing. And then it will also enable the further interrupts. Okay. So these are the steps that the processor will do on receiving an interrupt. So whenever an interrupt is occurring, the processor will be doing these steps. That is, first, when the interrupt is occurring, it will mask further occurrences of interrupts. That is, it will be doing that programmatically. It will mask all the other interrupts and it will save the current programs or current routines status onto the stack, and then it will execute the appropriate interrupt service routine. That is, whichever interrupt has occurred, that routine it will execute. And upon finishing the execution of the ISR, that is whenever the return instruction is coming, it will restore the context which it has stored previously onto the stack, and then also it enables the interrupts. Okay, so these steps the processor will be doing when the interrupt service routine or when the interrupt is occurring. Okay, next we can classify the ISR as two categories: non-nested and nested ISR. First we'll be actually seeing the diagram of a nested ISR, then we'll be discussing what is non-nested. Okay, nested ISR means, so this is the main routine which the processor was currently executing, and during the execution of this main routine an interrupt has come. Okay, so the first interrupt which has come is ISR1, and the processor has stopped whatever it was doing in the main routine, and then it has started to execute ISR1, and at that time a more priority interrupt has come. So if you compare the priorities of ISR1 and ISR2, ISR2 is having higher priority. Okay, so a higher priority interrupt has come, and at that time what will happen is the processor will stop the ISR1 execution also, and then it will go and execute ISR2, and only after finishing off with ISR2 it will return to ISR1, and only after finishing ISR1 it will go back to the main routine. So what has happened here is, when the processor was executing one interrupt, another interrupt has come in between the first interrupt. Okay, so this type of occurrences is called nested interrupts or nested interrupt service routines. Okay, so when one interrupt is being processed, another interrupt is coming, and then the processor will go and service the another interrupt which has come. Okay, so this type of occurrences of interrupt or interrupt service routines is called nested ISRs. Okay, now non-nested means, in this case the processor doesn't permit in between routine diversion. That is, when the ISR1 is executing, only after finishing with ISR1 then the processor will look into the other interrupts. In between processing of the ISR1, no interruption, no further interrupts is permitted. Okay, it will not look into another interrupts. If it has taken one interrupt, it will first execute and complete that interrupt, and only then it will execute the other interrupt. Okay, so this type of interrupts or interrupt service routines are called non-nested ISRs. Okay, processor doesn't permit in between routine diversion to high priority interrupts. So this type of interrupts can further be called by two names, or two terms can be used, which is called preemption and non-preemption. Preemption means, here one interrupt was being executed and it has been preempted by another interrupt. Okay, so this type of interrupts ISR are called preemptible or preempted. This process is called preempting. But if interruption in between is not allowed, means it is called non-preemptible, or it cannot be preempted. Okay, so this is again two terms which you can find along with interrupts. Okay, so these are the two classifications of interrupts, which are nested ones and non-nested one. So when the ISR execution starts, and auto return of saved values into the CPR registers on return from the ISR, means whenever it is executing with one interrupt, it will not permit another interrupt. It will be auto returning from that interrupt, only then it will be processing the other interrupt which is coming. Okay, so even if a high priority interrupt is coming in between, it cannot be processed. So the processor doesn't permit in between routine diversion. That is the important point here. Okay, next we are going to see the next topic, which is context switching. Context switching means whatever we have discussed now, whatever we have discussed about the saving of the current program status, everything, this process of doing the saving and restoring the data of a current program which the processor was executing, this process is called context switching. Okay, So when the interrupt is occurring, the processor will do three things importantly. That three things are saving all the registers, that is the program status word, program counter and current function status. These registers will be saved, and this saving is actually done to the stack. Okay. Then the next step or the next thing the processor will be doing is loading the next context, which is the interrupt. Then the third step is readjusting the stack pointer to start a new function. Okay. So these three things the processor will be doing on occurring of an interrupt. That is, first it will save all the registers and save the current status of the process which it was doing. Okay. And then it will load the next context, means it will load the interrupt service routine, and also it will readjust the stack pointer. Okay. So these three things it will be doing when an interrupt is occurring. And also after finishing with the execution of the interrupt, that is on entering or on receiving the keyword or the instruction which is return, which will be the last instruction of ISR, it will go back to the previous process which it was executing, right? And on encountering this return instruction, it will be doing these steps in reverse. Okay, it will restore all the registers, it will load the previous program whatever it was doing, and also it will adjust the stack pointer to the previous function it was executing. Okay, so earlier it was doing one earlier it was executing one program, and that time an interrupt has come. So what it will do is it will store all the registers and the status of the current process which it was doing to the stack, and then it will load the context or it will load the interrupt service routine, and also it will adjust or adjust the stack pointer, right? And on completing with the ISR, which is the that is when it is encountering the last instruction, that is the return of ISR, it will again restore the data from the stack. It will load the previous program, that is its context, it will reload, and also it will adjust the stack pointer. Okay, so these two things are also called as, that is these two things are called as context switching. These first, there is these three steps when the interrupt is happening, and when the return instruction is encountered, it will again do these three steps, right? That is in the reverse format. So these two cases are actually called as context switching. That is switching from the current program's context to the interrupt context. Also switching back from the interrupt context to the current program's context. These two switchings are called as context switchings. Now, one thing clearly we have seen here is the data is actually getting stored and it is getting retrieved from which memory, which is a stack memory. Okay. So when an interrupt is coming, the processor will save the current process, that is the current program's status, its registers and everything to which memory? To the stack memory, right? And this process of inserting a data to the stack is called push operation. Okay, so you can see here, this is the stack. It was only having one data, and this is the pointer to the stack, which is the stack pointer. Okay, now if you want to insert another data which is 10, what will you do? You have to increment the stack pointer by 1. Likewise, again we have inserted one more data which is 12, and further the stack pointer has been incremented by 1. So like this, when you are pushing the data to the stack pointer will get incremented. Okay, next operation, which is pop. So when the interrupt servicing is finished, the processor will return from interrupt to the current program context, right? At that time, whatever data we have stored to the stack has to be retrieved. So taking the data or retrieving the data from the stack is called popping operation. Okay, so when the popping operation is performed, the stack pointer is clearly getting decremented. Here you can see there is a data called E. Here it has been retrieved, and the stack pointer we have decremented. Okay, so it will go on decrementing when we are taking or retrieving data from the stack. Okay, so these two operations are actually very important when we are discussing the context switching area. Okay, so that's all about this video, in which we have actually discussed a lot of things. We have covered almost everything from the interrupt area. We have discussed what is an interrupt, what are the sources of interrupts, what are the sources of hardware interrupt, also software interrupt, what are the classifications. Also, we have seen what is interrupt service routine, nested ISR, non-nested, and also we have seen what is context switching, and also we have seen the push and pop operation. Okay, so this is actually a quick revision video of all the areas of interrupt. So I'm really hoping that you found the video useful. If yes, please to give it a thumbs up. Also share it with your friends. And if you want more videos, please to subscribe to the channel. Thanks for watching and keep on watching.